Alright, let's try example 2.1. So we do it together one by one. A factory produces steel sheet whose wicks are known to be normally distributed with a standard deviation of 2.4 kilogram. A random sample of 26 sheets had a mean weight of 3.14 kilogram. Find a 99% confidence interval for the population mean weight and give an interpretation of the parameter estimate. So from the equation given, we know that the first sentence, a factory produced station are known to be normally distributed with a standard deviation of 2.4. So standard deviation here is population because it is normally distributed. It is known before that the standard deviation is 2.4. So sigma equals to 2.4. Okay, next, a random sample of 26 sheets. Then they get a sample n equals to 26. Had a mean weight. So from this sample 26, they give the mean x bar equals to 3.14 kilogram. So the question asks you to find a 99% confidence interval. So confidence level 99% for the confidence interval for the population mean. And don't forget to interpret. Okay. So first step, you extract the information. So I give you the information here. Right? Then we want to choose which formula you want to use. Okay, there are 3 formula. So which formula do you want to use? So let's look at here. They give you the sigma and an x bar. So which formula you want to use? So open your stat table, page 5. You will find this one, confidence interval for mu. There are 3 formula. So the first formula here is used when you have sigma or sigma square. When sigma or sigma square is given, use formula number 1. When you don't have sigma or sigma square, look at the sample size. N greater than, if your n is greater than 30, use second formula. If your n is less than 30, use the third formula. What is the difference between second formula and the third formula? So second formula we will use Z table. Third formula we will use T table. So from our question just now, they give you sigma. So they give you sigma. Can you use formula number 1? Yes, because sigma is given. So straight away use formula number 1. So what are the formula? The formula is x bar minus z alpha over 2 sigma over square root n for the lower limit, and for the upper limit x bar plus z alpha over 2 sigma over square root n. Okay, so let's look at here your formula. Do you have the x bar value? Yes. Do you have the sigma value? Yes. Do you have the n value? Yes. Now you don't have the z alpha over 2 value. So how you want to find z alpha over 2 value? So from the confidence level 99%, so alpha is 1%. Convert into decimal places, alpha is 0.01. So z okay, alpha is 0.01. So because of confidence interval, z alpha over 2, right? So alpha need to divide by 2. 0.01 divided by 2, you will get 0.005. So z 0.005. Where can we get this value? Get from your stat table, z table. So look at your stat table, go to this table for percentage points of the normal distribution. How you want to read? So first, you look at the alpha. our alpha just now is 0.005. So find alpha 0.05. So alpha is here. Alpha. I'll make it bigger. Alright. Okay, this one is alpha, alpha, alpha. Now our alpha is 0.005. So where is alpha 0.05? Here. Alpha 0.05 is here. So the z 0.005 is equals to, look at the value to the right, 2.5758. Okay, so our z 0.05 is 2.5758. Okay, now you get the value of the z alpha over 2. You have this value now. So what you need to do next is you substitute all into the formula. So our x bar is 3.14 minus z alpha over 2 is 2.5758 times sigma is 2.4 over square root n is 26. This one is for the lower value, or you can just simplify plus minus. Okay, so minus for the lower value, plus for the upper value. So you will get the answer. Put it into your calculator correctly. Make sure you do this one first. Okay, make sure you put this one first, and then 3.14 minus this answer. So the final answer will be 1.9276 and 4.3524 kilograms. So don't forget the unit. Okay, done for the confidence interval. So last you have to interpret. So how you want to interpret? We will interpret like this. We are how many percent? 99% confident that, so you copy from this, that the population mean weight, that the population mean weight, okay, and then you put lies between your answer here, lower boundary and the upper boundary, lies between 1.9276 kilogram and 4.3524 kilogram. So don't forget, in your interpretation you must state the population mean. The word population is very important because we want to estimate the population mean. So this is your answer. Okay, example 2.2 is the continuation of example 2.1. So from example 2.1, we know that we have to use this formula, x bar plus minus z alpha over 2 sigma over square root n. So from the definition, I have explained this before. So here is your E. Okay, the estimation error. So the E is equals to z alpha over 2 sigma over square root n. Okay, you have all the information there. Okay, so the z alpha over 2, so E is equals to 2.5758 times sigma is 2.4 over square root n. So your E is equals to 1.2124. Okay, so this one is your estimation error. Right. So if you look at example 2.2, based on example 2.1, investigate the effect of sample size, standard deviation, and confidence level value, and the confidence on the confidence limit if you have changed the sample size to 100. So what will happen if you change your sample size to 100? Okay, if you remember, we have the information that we have in the slide before, where when you increase the alpha, okay, hold on. Okay, if n is increases, your E will be decrease. If your sigma is increase, E will be increase. If your alpha is increase, E will be decrease. Right, so A, change the sample size to 100. So you want to change the sample size to 100. Before this, n is 26. So you change n into 100. So you increase the n. So you increase the n, what will happen to the E? E will be decrease. Means that the estimation error is small. So it is good. Okay, so this one for A. For B, change the population standard deviation to 1 kilogram. Before this, the sigma is 2.4. Now change sigma into 1 kilogram. So you decrease the sigma. So if you decrease the sigma here, if you lower the sigma value, E also will be lower. So the estimation error is decreased. Right. And then for C, change the confidence level to 95%. So before this, confidence level is 99%. So alpha is 1%. Now, confidence level is 95%. Alpha is 5%. So alpha is increasing. So because of alpha is increasing, your E will be decreased. So E will be decreased. Okay, so these are the information what will happen to the error if we change the sample size, if we change the population standard deviation, and if we change the confidence level. You have to play around with the formula. So you have to remember this one. If we increase sample size, your error will be decreased. If you increase the standard deviation, your error also will be increased. If you increase the significant level, the error will be decreased. Alright? Okay, let's look at another example. Example 2.3, confidence interval for one population mean. So read the question. A random sample of 25 bulbs was selected. So straight away you know that n is equals to 25. They take the sample and the specified brightness were evaluated. So specified brightness, they talk about brightness. So brightness is the variable for each bulb by measuring the amount of electrical current required. The sample mean of the electrical current required for the bulbs is 280.3. So sample mean is X bar. So X bar is 280.3 microamps, and the sample standard deviation. So sample standard deviation is S equals to 10.3 microamps. Construct a 90% confidence interval. So confidence level is 90% for the population mean and interpret your answer. So you have to construct confidence interval for 1 mu. Okay, now you have the n, X bar, S, and the alpha. So which formula you want to use? Okay, look at the formula. Can we use formula number 1? Did they give you any sigma? No, you do not have any sigma. You only have n, X bar, and S. So you cannot use formula number 1. Can we use formula number 2? Yes or no? Sigma is not given, right? But you have to consider the sample size. So look at back. Our sample size is 25. Less than 30. Can we use formula number 2? No, because number 2 is for greater than 30. So you have to use formula number 3 here. So if you notice, we will use T here, where the nu is equals to n minus 1. Okay, so the formula you have to use is X bar plus minus T alpha over 2 nu, and then S over square root n, where the nu is equals to n minus 1. Alright, so you have the X bar value? Yes, here. Do you have the S value? Yes, 10.3. Do you have the N value? Yes, 25. Now you don't have this value, T alpha over 2, no. So T alpha over 2, no. Okay, we do it one by one. From the confidence level 90%, alpha is 10%. So alpha is 0.1. So alpha divided by 2, you will get 0.05. So nu is equals to n minus 1. So our n is 25 minus 1 equals to 24. So T 0.05, nu is 24. Where can we get this value? From your stat table. So look at your stat table. Go to the table 5 percentage of the T distribution. Okay, if you look at here, this one is your nu. Okay, where the nu is equals to n minus 1. Okay, this one is your alpha. Okay, so now our alpha is, look at back, our alpha is 0.05, nu is 24. 0.05, nu is 24. So look at here, find nu 24. So nu 24 is here. Okay, and then our alpha is 0.05. 0.05 is here. So you go to here, go to the midpoint. Ta-da! So here. So T 0.05, nu 24 is equals to 1.7109. So you put it back. Here is 1.7109. So now you got this value. So what you have to do next is you just substitute all the information into your formula. So the formula is x bar plus minus T alpha over 2 nu S over square root n. Okay, and then you substitute x bar is 280.3 plus minus T alpha over 2 nu is 1.7109 times S is 10.3 divided by square root 25. Okay, so I remind you, or I suggest you to calculate this one first into your calculator, and then 280.3 minus this answer, you will get the lower boundary is equals to 276.7755, and the lower boundary 280.3 plus this answer, you will get 283.8245, and don't forget you have the unit micro amp. So if you notice here, your lower boundary must be less than your upper boundary. So don't forget, if you think that your lower boundary is greater than your upper boundary, then your answer is wrong. Lower boundary must be less than your upper boundary. And last, we have to interpret. We are how many percent? 90% confident that the population mean lies between 276.7755 and 283.8245 microamps. That's all. Okay guys, example 2.4 is a little bit different from previous example. So read the question carefully. A telephone company wants to estimate the mean number of minutes people in a city spend talking long distance with a 90% confident. Okay, so 90% confident, we know that 90% confident, so confident level is 90%. Okay, from past record, so remember, so note that past record means that it is a population. Okay, from past record, an estimate of the standard deviation is 12 minutes. So sigma equals to 12. Why sigma? Why population? Because past record is population. population. So the question is, what is the minimum sample size? So they ask for sample size so that the estimation error of the mean lies within. So the error is plus minus 5. So the question asks for n. The question not ask you to construct confidence interval. The question asks you for the sample size. So what you need to do? So from the question here, you know that they give you sigma equals to 12. So sigma square is known. So if your sigma square is known, which formula you want to use? You will have this formula: x bar plus minus z alpha over 2 sigma over square root n, if you want to construct the confidence interval. So we know that in this formula, the z alpha over 2 sigma over square root n is your estimation error formula. So you extract this out. So the error is equals to z alpha over 2 sigma over square root n. Okay, do you have the e? Yes, we have the e. E is equals to 5. So you substitute. 5 is equals to, do you have the z alpha value? No, you don't have the z alpha over 2 value. So what you need to do is you have to find the z alpha over 2 values. So confidence level 90%. Alpha is 10%, so 0.1. Alpha over 2 is 0.05. So z 0.05 is equals to, look at your stat table, alpha 0.05 is here. Oh, sorry, this one is alpha 0.005. Sorry. So again, right, alpha 0.05 here. Okay, and the z alpha is 1.6449. So here is 1.6449. So you put back into your formula. Okay, so our E is 5. So 5 is equals to z alpha over 2 is here 1.6449. Sigma is 12 and you don't know the n. You want to find the n. Now can you find the n? Okay, so we put here 1 point sum algebra here. Sigma is 12 over square root n equals to 5. So you put n here, you put 5 here, and then you make n into the subject. You will get the n is around 15.5848. So n is 16. Okay, try to do it on yourself. So this one is just a simple algebra here. Okay, calculation, how you want to put n as your subject. Okay. Alright, for example 2.5 is also a little bit different because it is about the one-sided confidence interval. How you want to know that your question is one-sided? So you have to read the question carefully. They have mentioned there, a packet of baking powder supposed to have a mean weight of 200 gram. Okay, the distribution of weight is normal and the population standard deviation is 7 gram. So you have here mu is equals to 200, and then the distribution of weight is normal and the population sigma is 7. A random sample of 9 packets, then they take sample 9 had the following weight. Construct a one-sided. So if you look at here, we have mentioned construct a one-sided upper bound. So one-sided upper bound for a 98% confidence interval for the population mean weight. So you have here one-sided upper bound. So this is a one-sided. So remember that if one-sided alpha stand alone, you don't have to divide the alpha by 2. So from the information here, they give you sigma. Sigma equals to 7. So your formula is x bar plus minus z alpha sigma over square root n. So if you notice, alpha is not divided by 2. Okay, so you have the x bar value. Do you have the x bar value? Yes, you can get from this data. They give you data, right? This one is mu. You cannot use mu, but you have to get the x bar from this data. So x bar is equals to, when you substitute your data into your calculator, you will get x bar equals to 210.2222. So x bar is here, and then sigma equals to 7 and equals to 9. So now you don't have the z alpha, so you have to find the z alpha in your stat table. So I give you the answer here. Z 0.02 equals to 2.0537, and then you substitute all into the formula. You have got this formula, and then substitute all into the formula. You will get this answer. If you notice, this answer have 0 and 215.0142 gram. Why 0 for the lower boundary? Because this is a one-sided upper bound. So upper bound, your A equals to 0. So this one is your B. Right? So you have to read the question carefully. It is one-sided upper bound or one-sided lower bound. If it is lower bound, your answer will have A have value and this one is 0. Okay, look at the question carefully.